Hello everyone, welcome to WB Institution, the online education app. In the previous classes, we have discussed about design of mission elements. Now, in this design of mission elements, we are going to design about clutches. So, everyone will be knowing what is a clutch. Now, in simple engineering terminology, clutch is nothing but a mission element which is used for engaging and disengaging driver and driven shaft by applying some medium, that is a mission element in between driver shaft and driven shaft. So let us assume there are two shafts. So this is a driver shaft which is rotated by the power, which power is given to this shaft. So the main power is getting output in this shaft. Now there is a driven shaft which we want to make it also rotate, which will give the output power to the wheels. Now we have to contact both these shafts, so driver shaft and driven shaft. Now if we contact two shafts, then two shafts will rotate automatically. Now at a certain condition, we want only driver shaft to be rotated and driven shaft to be stationary. Now at these conditions, we cannot every time switch on or switch off the driver pulley, so that may cause lots of energy for the propulsion of this driver pulley. So in that cases, we use a mission element, an element which is known as clutches. So this clutches is used to transfer the motion from driver shaft to driven shaft, but when the motion is not needed from the output, that is to the wheels, then we can directly apply the clutches, so that the driver pulley will be rotating and driven pulley will be in a stationary condition. So this mission element is known as clutches. So clutches are mainly two types. One is positive clutch and other one is friction clutch. So positive clutches, in positive clutches there are friction generated, there is no friction generated, and there is a positive engagement between driver shaft and driven shaft. And in friction types of clutches, there is a slip is produced during engagement. So in case of positive clutches, there is no slip produced in that type of clutches. Coming to second point, in positive clutches there will be sudden engagement. So there will be sudden shocks will be applied in the driven pulley, also when engaging with the driver pulley. So in friction pulley there will be smooth engagement, so there will be no sudden impact loads will be applied on the clutches. Next is, it cannot be used in high speed. So wherever the high speed driven pulley is required, there we cannot use positive type of clutches. So at that places we can use friction type of clutches. So we can use friction clutches at even high speeds also, because there will be slip provided, and due to this slip this engagement can be smoothly engaged with the driver and driven pulley. So some examples of positive clutches are power press and rolling mills, and examples for friction clutches are used in automobiles. Now let us discuss each by detail. So example for a positive clutch, we can say it as a jaw clutch. So jaw clutch, it is a positive type of drive. So here we can see two shafts. This is a driver shaft and this is driven shaft. So there are teeth in driver shaft and also teeth in driven shaft. So this can called as a male and this can called as a female. So there are teeth in both the shafts. When engaging directly, it will be engaged to the male shaft. This is in a disengaged condition. So if it is in an engaged condition, then let us see how it looks. So here we can see this is the way how the engagement takes place in case of jaw clutches. So the maximum amount of power transmission is generated in between driver shaft and driven shaft, and there will be a minimum amount of energy losses. So here there is no friction is generated in these two types of shafts in this type of clutch. So this is known as a positive drive, and in a positive drive the efficiency is higher, and also this can be used in low power transmission, low speed transmission conditions, that is in a printing press, power press or rolling mills. We can see this type of clutches used in these applications. Next type of clutches, that is friction clutches. So these are mainly classified into three types. One is plate friction clutch, cone friction clutch, and centrifugal friction clutches. So these plate friction clutches are further classified into two types, that is single plate clutches and multi plate clutches. So these single plate clutches main applications are used in a big vehicles, that is cars, trucks, buses, etc. Why? Because the construction of single plate clutches is in big construction, and multi plate constructions we can see in motorcycles. This type of clutches is used in motorcycles. And cone type of friction clutches, it is used in racing cars. Why? Because there will be a rapid movement of the clutch happens in between driver and driven pulley, driver and driven shaft. That's why it is used in racing cars. And centrifugal, it is totally a different type of concept from plate and cone type of friction clutches. So this type of centrifugal clutches are used in mopeds and also used in golf carts. So we can see in golf carts this type of friction clutches are used. Now in each type of clutches, let us derive the design equation. So what we have to derive exactly in these types of clutches? So first, single plate friction clutches. So in this single plate friction clutches, we can see in the diagram, it is a construction of single plate clutches. So there will be a driver shaft and driven shaft. So in between these two shafts, two plates are fixed. So the plate fixed to the driver shaft is known as a flywheel, and the plate fixed to the driven shaft is known as a pressure plate. So in between these two plates, there is a plate which is used to transfer the motion from driver shaft to driven shaft, that is clutch plate. So this we can say it as a clutch plate. Now in this clutch plate, we can see an area which is in a maximum width, that is known as a friction clutches, that is given by a friction liner. So friction liner is used in between two plates. So there is one plate here and there is other plate. In between there is a plate which has a friction liner. So when it is connected with the in between two shafts, so when a driver shaft and driven shaft is came closer, then by means of friction in this clutch plate, the motion is transferred from driver shaft to driven shaft. So this is an working principle of a single plate clutches. Now let us derive an expression for single plate clutches. So here mainly we are discussing about the pressure acting on the clutch plate and also the amount of torque which can be transferred from the driver pulley to driven pulley. So the main result which we are going to calculate in design of single plate clutches or any types of clutches is the amount of power transmitted. So in other terms we can say the power transmitted, we have to calculate the torque. So the torque will be the main agenda to calculate in this design of single plate clutches. So here let us see a line diagram. So in this line diagram we have taken the construction of a clutch plate. So we can see the clutch plate here. So here this is an inner dia and this is outer dia. This green line is an outer dia. So the inner diameter, the radius is given as R1 and the outer diameter radius is given as R2. So we can see the cross sectional view here. So we can see the cross sectional view. So in this cross sectional view we can see here there are friction liners produced in the top view and also in the bottom. Now there is a opposite force acting on the clutch plate. That's why in a vehicle when you are driving always the clutch will be activated to the driver and driven shaft. So when we need to change the gear, we will press the clutch. So we will pedal on the clutch so that the clutch disengages from the driver shaft. So when the clutch is engaged to the driven shaft, some pressure is applying on the clutch plate. That's why that pressure will be constantly applying on the clutch plate. So there is a pressure acting. So by means of that pressure only, it is going to engage the driver shaft completely. If there is no pressure, then it will rotate freely. The clutch plate will rotate freely. Now when this clutch plate is engaged with the driver shaft, then there is a certain pressure. So that pressure is given here as P, and when we are going to apply pedal on the clutch plate, that is at the time of disengaging, we give some axial load to the clutch plate. Thus that load is known as W, which is axial load. Now let us see what are the terminology used in this derivation. So here R1 is the inner radius of the friction liner, R2 is the outer radius of the friction liner, W is the axial load of engagement and disengagement, T is the maximum torque transfer capacity, mu is the coefficient of friction, and P is the maximum pressure on friction lining. That is, we explained it before. Now we want to calculate both these values W and T with respect to R1 and R2. So that gives the result of the design of single plate clutches.